Hello, my name is Blake Hlavaty, and we're going to go through a 10-minute open SDN NFV demo. Let's get started. So here's the topology we're going to use. As you can see, we're going to have one open vSwitch here in our topology, and we're going to have 3 hosts down here. You can see them at the bottom. And we're going to control our open vSwitch with a POX SDN controller. POX is going to communicate with our open vSwitch using an open flow southbound protocol. So a little closer, we're also going to run on top of our SDN controller. These will be VNFs, or virtual network functions. We're going to run a firewall application, and it'll have its associated access control list, or ACL. We're also going to run a layer 2 switching application to help us route traffic. Alright, so I'm using a VirtualBox environment with Mininet running in VirtualBox. So let's go ahead and build that topology that we just looked at. So here's our command to build the topology. Sudo superuser or superdoer Mininet, that's how you access the Mininet application. And then here's your topology command. So we're going to do topo topology. Single means just one controller, and we looked at remember from our topology we just have one switch. Single means one switch, and 3 hosts. So the 3 means hosts. And Mininet actually comes with an internal controller, but we're not going to use that. We're going to use a remote controller, the POX controller that we looked at. And this final command, the --mac, is going to give us really simple, easy to read MAC addresses for all of our hosts and switches. So all our MAC addresses are going to be like 000 with a 1 or 02 or 03 at the end. So it makes it really simple. So all right, let's build it. Okay, so here is our topology. Created the network, added controller, built our 3 hosts, our 1 switch, built the links between our hosts and our switch, configured the hosts, and started the switch. So there you can see we built the whole topology right there. So the next thing we want to do is let's actually go and look inside our open vSwitch. We just want to take a look, and I'm going to use this dpctl command, which is going to show if there's any flows in our flow table of our open vSwitch, which our controller is talking to our vSwitch with open flow. And you can see right now, no flows. So let's go back to our presentation, and we're actually going to kind of show what it looks like inside of our open vSwitch right now. And this would be our flow table, kind of represented here. Let's simplify it a little bit. But there's no flows. The only thing in there, and it comes pre-programmed, is sort of these 2 wild cards at the bottom. They'll match on anything. And then the action that it's supposed to take is send to the controller. So any packet coming in right now is just going to get sent up to the controller because the switch essentially doesn't know what to do with it. Okay? Excellent. So let's go back over here. So we got a couple applications we're going to run, right? So let's take a look at our firewall. We're actually going to get into the code here and look at the code for the firewall application that we're going to run. And let's scroll down. So this is all written in Python. So POX applications for the POX controller written in Python. You can see some of the imports and APIs here. This next section I want to scroll down to. This is where you go to find the firewall policies, or the ACL. There's the address there, so the firewall knows how to find its policies, and we'll look at those next. And then now let's look at the next section is sort of how to read that policy file, which is just a .csv file. We'll look at that more. And then down here is kind of the meat of this application, basically telling the controller how to send the OpenFlow messages down to the open vSwitch. And you can kind of see this line right here. I'll use the other cursor. This line right here is really the heart of this application. Basically what it says is, hey, if you get any match out of my access control list, then what I want you to do is send it out of port, right here, port, and then it says none. Essentially what it's saying is port none or drop the packet, right? That's kind of what it's saying here. So that is our firewall application. There's a quick look. So let's look at the access control list now, and then we'll boot up the controller. So looking at, here's our access control list right now, right? Super simple. It's a .csv file. CSV is comma separated values. It's a spreadsheet in a text format, right? So, you know, my columns are ID, MAC 0 and MAC 1, and there's just an ID number, and then the MAC address. This is actually the MAC address for host 1. This is the MAC address for host 2. And essentially what I'm saying is to my firewalls, hey, I want you to block all communications between host 1 and host 2, and then it's going to send the appropriate flow table messages down to the Open vSwitch to make that happen. So what we'll do next is we'll go to our, we're going to start up our POX controller. See, there it is. You can see we need to read Python. Here's the application for the POX controller. The layer 2 learning, that's our layer 2 switch, and then firewall, that's our firewall application. So we'll start both of those up. You can see it came up and it's connected. So now we're going to go back into and log into our Open vSwitch. Let's make a little space here. We're going to log back in and see if we have any new flows in there. And you can see, you know, before we didn't have any flows. Now we have some flows entered in our flow table. And just to kind of get to the point here at the end, you can see anything that matches on a source MAC. It says DL SRC, so SRC is source, DL is data link for the data link layer. You can see anything that matches on MAC 01 for the source and MAC 02, then the action is none. So essentially to drop the packet. Then you can also see there is a second one for the reverse direction from MAC 2 to MAC 1, and for some reason it also blocked 1 to 3, and that's because I changed my ACL and I probably didn't save it. Watch this. So we're going to shut down the controller. So there, we stopped it, but to actually, I'm going to actually shut it completely down. There we go. Now let's reboot the controller here. Back up. Now we're going to go back into our Open vSwitch and resend those flows. Okay, that's what I expected. There you go. Now we have our two flows that are blocking all traffic from host 1 to host 2. So the source 01, destination 02, action drop, source 02, destination 01. So you have to send a flow for each direction of the traffic. So one from 1 to 2 and one from 2 to 1, right? So it blocks all of that traffic. So now let's look at our topology just real quick so we can see, you know, a little easier format. This is essentially what our controller looks like now, right? Before we didn't have any flows except for the wildcards at the bottom that are going to send the packet to the controller. We have two new flows now, and anything that matches on source 1 or 2 will get dropped. Anything that matches on source 2 and destination 1 will get dropped. So, you know, kind of if you take this example packet, you can see it as a source 01 and a destination of 02. It would start at the top of the flow table, and once it hit this line and there was a match on 01 and 02, then it would come across to see what the action was, and the action on it is to drop that packet. So this packet would get dropped, right? So let's kind of see this in action here. Let's go back to our topology. And what we're going to do, let's just prove that we can pass traffic, right? So let's go from H1 and we'll say ping H2. There you go. Actually, let's do 3, right? Because that's not blocked. So this will show that we can pass traffic. There you go. And I'll Control-C to stop it. So you can see we transmitted 4 packets and 4 received. Great. So we can pass traffic. So now let's test our firewall. H1 ping H2. There you go. So if our firewall works, this should not pass, right? So it's trying. Look, there you go. Host unreachable. 6 packets transmitted, 0 received. So our firewall is working. We can even try the other way. H2, ping H1, just to be sure. There you go. So I'll stop it. 8 packets transmitted, 0 received. So our firewall is up. So let's just show that we can kind of make a change. I actually kind of showed this a little prematurely earlier, right? But we'll look at it again. Now we can add back in, we'll go ahead and basically completely isolate H1. So let's look at our topology for a second. Right now we have H1 to H2 blocked, but now we're going to also block H1 to H3, right? So we'll completely isolate H1. So to do that, we want to pull up our ACL, and I'm just going to go into my, I'm using an Emacs text editor here. Comes pre-installed on your the Ubuntu load for Mininet. And I'm just going to paste that line. And what we'll add is a 3 right there, right? Don't forget to save it. Put that down. Now, my POX controller isn't super sophisticated, so to implement that change, I actually need to restart it, right? My setup isn't that sophisticated, so let's go ahead and close out, and we'll enter the shutdown command. So now it's totally down, and then we'll restart the controller. So it's back up, and it's connected. Let's go back. Let's take another look inside of our Open vSwitch so we can see the new flows. Make sure they're in there. Okay, so now you can see before we had the 2 flows, now we have 4 flows. So we're not only blocking all traffic from host 1 to 2 and from host 2 to 1, we're also blocking traffic from host 1 to 3 and host 3 to 1. So host 1 is completely isolated from all the other nodes on the network. So let's test that out in the topology. Well, real quick, we can look at what that would look like. Inside the Open vSwitch, it would look something like this, right? Blocks from 1 to 2, and from 2 to 1, and from 1 to 3, and from 3 to 1, right? So here's another example kind of packet with a source MAC address of 1 and a destination MAC address of 3. And if you scroll down here where it's source 1 and destination 3, it's going to get an exact match, and it comes across and the action says drop, right? In our flow table. So let's go back. First, let's make sure we can pass traffic. So let's H2 ping H3. That should work. Okay, great. I'll stop that. Control C, and you can see 4 packets transmitted, 4 received. Perfect. Now let's test out our new ACL entry. So we're going to go from H1. And we're going to ping H3. So if our firewall is working, this should block it. Look at that. Not passing any traffic. Oops. 11 transmitted, 0 received. So you can see our firewall is working effectively. Just for one last check, let's go the other way. Oops, I was going to go... Go. 3 packets transmitted, 0 received. So our firewall is working. We've completely isolated H1 from both H2 and H3. So that's all for our Open SDN NFV demo. Quick thanks to some of the references: mininet.org, Nick Feamster Coursera course, and some of our friends there on GitHub who helped with some of the code. So thanks a lot, and have a good one. Bye.